Heads up, y'all. All right. Shh. So, thank you for being good with the sub. Didn't really get any bad notes from you guys. All right. Now, on Thursday, I had you guys watch that video. It was like not even 20 minutes. And it was on measures of central tendency. So that's just a fancy name for things that you already know about, which was mean, median, mode, and range. The only things that were probably like relatively new to you was the quartiles, which we already learned about when we did box plots, and IQR interquartile range. Interquartile range is probably the newest to you. Yes. Yeah, it looks different. No. Yeah. But I was now, the interquartile range, if you have a box plot, so say we had this box plot, looks something like this. All right, your interquartile range is basically how big your box is. Now, does anyone remember how you find it? Embry. You do Q, guys, stop talking. You do Q3 minus Q1. You're basically finding the range of the quartiles. All right, that's exactly what interquartile range is. You're finding the range of the quartiles. So you subtract the biggest quartile minus the smallest quartile, or Q3 minus Q1. Now, this is important because it'll help us with finding outliers. It's part of its formula for finding outliers. So, today, what we are talking about with 9.5 is we're now going to use those measures of central tendency that you should have learned in the journal from last week to describe data sets. So we're looking at the shape that the data forms, what its centers are, and how we can tell which ones are the most useful, its outliers, and its spread of data. All right? So now we're looking specifically at more descriptive details with data. All right? So that journal that you have, it is a trifold. So it should open up so that you have the 4 flaps for spread, outliers, shape, and center. You don't have to. It's up front. Now, we're going to go ahead and get started. So you should have that journal out. Now, we're going to start by talking about the shape of data. So that it should be the top top left corner of your foldable. Now, when we think of the word shape, what typically comes to mind? Square, what else? Circle, triangle, rectangle. Basically different figures, right? All right. Shape is basically asking what our graph looks like. Does it look like it's symmetrical? Does it look like it's skewed? Does it look like, it's basically asking us what's going on with our data. Now, the median and the mean are 2 factors that play into what shape our data will take. So even though if we don't have a graphical representation of our data, so it could be a dot plot, it could be a histogram, box plot, we can tell how the data is skewed. All right? So the pictures in here are all histograms. But you can also figure it out from box plots, you can figure it out from dot plots. It's pretty much about the same. All right? So, heads up, guys, come on. So when we're talking about shape, the definition of shape is basically we're looking at whether it's approximately normal, whether it's skewed right or skewed left. And I'm going to explain what that means. So, in later classes, you may hear the word normal curve a lot. All right. Now, normal curve kind of describes a very specific shape in the data. All right. Typically, we're looking for it being symmetrical. So if it's normal, it's symmetrical. That's another way to describe it. Meaning, if we look at this data over here, if I were to draw a curve around the histogram, all right, that curve looks like if I cut it right in half, it would be symmetrical. So if I cut it in half, this curve, I could fold it over each other, be the same size pieces. It's symmetrical. Yes. Wait till break. Now, this happens when your mean equals your median. So if you weren't looking at a graphical representation of the data, your mean also equals your median. Now, there are two types of symmetrical graphs. There is this one that they have for us, which is known as the bell curve, because it looks like a bell. If you drew the curve itself actually looks like a bell. And then there's what we call the U curve. So a U curve looks something like this. So instead of it getting from smaller to taller, it's going in the opposite direction. So this would be what we call U shape. It's still symmetrical, but if I drew a curve to describe it, it would look more like a U. So this is still symmetrical, but it's just U shape. But for both of these, what they have in common is that the mean or the average is equal to the median or the middle. Now, if you're looking at the dot plot, same thing. If you drew a curve over it, it would look symmetrical. Same thing with a box plot. If the box would be fairly centered. All right. Now, we then have skewed right. Now, if we look at the actual graph that they give us to describe skewed right, it looks like most of our data is on the left. When we're talking about skewed, we're not looking at where most of the data is. We're looking at where the tail of the curve is. So for skewed right, if I was to draw the curve, my tail would be right here in the curve. The tail is on the right side. So since the tail is on the right, we say that it's skewed right. Now, this happens if the median is less than the mean. So make a note, if you don't remember what the sign is, it's less than. The median has to be less than the mean. And the reason that is that if we're looking at histograms typically the center when we look at histograms is typically the mean. All right. But with the median, we know the median is the middle number, the mean is its average. based on whether the average or the middle is bigger depends on which one is controlling how it's being pulled. So imagine like it's a game of tug of war, all right? If they're equal to each other, it's a draw, all right? But if the median's less than the mean, meaning the mean has greater force, it's going to the right, all right? It's getting skewed to the right because the mean is winning. Now, there's more reasons behind that, like more like analytical reasons behind that, but I just want you to make sure that you can recognize the graph and why it is. All right. Whereas if the median is greater than the mean, the median's what's winning, so it's pulling to the left. All right. Now, if you ever take AP stats with Miss Sherman, or even in some of your later stats parts of Math 3 mainly, you'll learn why that is more often. For right now, I just want to make sure you can recognize it. All right, so if that tail is on the right side, it's skewed to the right. Now, if the median is greater than the mean, we're skewing left. Meaning if we were to draw our curve, the tail is clearly on the left. All right. So again, in this class, the only thing you need to know is how to look at the representation and identify it as its shape, whether it's symmetrical, skewed right, or skewed left. Also, if I asked you to describe the shape and I gave you its median and mean, you should also know what that shape is as well. So whether it's symmetrical because the median equals the mean, whether it's skewed right because the median's less than the mean, or if it's skewed left because the median's greater than the mean. All right? That's all you need to know for this class. Now, let's look at some examples. So this very first graph right here, what do you think the shape of this graph is? Say that again. Skewed right. Because if you drew the curve, it looks like that tail is on the right. So because it is, we'll say that this is skewed right. Now, what about this next example? What do you guys think? Someone different. Elise. It's a bell curve, meaning it's what word? Symmetrical. Good. So this is a symmetrical, and if we want to get more precise with it, we'll call it a bell. So a symmetrical bell. All right. So since it looks like it is fairly even on both sides, it's symmetrical, specifically a bell. What about this last example? Gary. Skewed left. Good. So if we drew the curve, the tail is clearly on the left, so it's skewed left. Now, one more example that I want to give you guys. If I give you a median of 86 and a mean of 90, so let's say I had a data set, I took its measures of central tendency, the median is 86, the mean's 90. What's its shape? Say it again. It's right skewed or skewed right. Why? Right. So, because the median is less than the mean or the mean is greater than the median, it's skewed right. So if I were to actually graph the data, it would look like that tail is on the right side. Any questions on shape? Guys, heads up, please. All right, now let's look at center. So I kind of already mentioned this, but when we're talking about center, the center of the data can be described as either the median or the mean. Now, these are kind of interchanged a lot depending on the type of data that you have or what type of graphical representation that you're looking at. For example, what would be the most logical center that you have if you're given a box plot? Median. Why? What does the box plot automatically have in it? It's median. So in a box plot, in order to build the box plot, we got to have its median. So if we're given a box plot, we're typically looking at the center as the median. Now, mean comes more so when you talk about normal curve or bell curve. That's more of a Math 3 thing, AP Stats thing. But the mean comes into play a lot with that. And the mean will come into play more so when we talk about standard deviation tomorrow. The mean's going to be the center that we focus on the most. All right? But just know that both median and mean can be used to describe the center of our data, but depending on what we need it for, we interchange them. All right? Now, just to recap, your median is your what of your data? It's the middle. So it's the middle number, which means if you were given the data and had to do it by hand, you'd first have to do what? Put it in order from least to greatest. Least to greatest. Now, the mean is found by adding all the values in a set of data and dividing by the number of values. In other words, we're taking a what? What's another name for mean? Average. Good. So in other words, we're taking an average. So remember, mean and average will probably be interchanged a lot. So you need to know that when I say mean, I also mean average. They're synonyms. They're exactly the same thing. Now, let's look at the second example. Let's do that one together. If I want to do the median first, what's the first thing I got to do? Put them in order from least to greatest. So I have 60, 75, 80, 80, and 90. All right, so then if I cross out on both sides, left and right, my median's what? 80. So my median is 80. Now, if you take the mean, you're going to add up all those numbers and divide it by what? 5. There's 5 numbers in that data set, so go ahead and do that in your calculator. It is 77. So let me ask you this, because we're all about connections in math. What's the shape of this data set? Skewed left. Why? Right. The median's bigger than the mean, so this data set would be skewed left. All right. I want you guys to take a minute. Try that first example on your own. So do the first example on your own. So the one above the one we just did. Skewed left. That's all I wrote at the bottom. Skewed left. So what I'm gonna do is instead of just doing the instruction, I'm gonna put this test for you. So we're looking here, I'm going to do 17. Or look at this better, so still affects like your final grade, but you'll have all the notes. So it's very easy to get back. All right, thumbs up if you're ready. Wait till break, I'm almost done. All right, so someone raise their hand and tell me what they got for the mean, Foster. 3, good. Someone else raise their hand, tell me what they got for the median, Chris. 3, good. So you should have gotten 3 for both. Thus, if I asked you the shape, what is it? Symmetrical or bell curve. Now we can't quite say that it's bell curve because we don't know what the data shape is, but we can at least say it's symmetrical. But we don't know for sure whether it be a U curve or a bell curve. All right, so we're going to go ahead and take our 5-minute break and come back and do the other half of the notes. Oh God. What? Why? Oh, that's something I need to class. Ah.
I'm so hungry. So now I did food. Yeah, where's Chris at? Dang, walk. Chris, you love me? Say it loud. Chris, can we get like
Bro, it's certified to sell.
Oh no.
Certification.
Alright, guys. Alright, break's over. Let's get back to it. Alright. So, now we're going to be talking about outliers. Alright, now we already know the general definition of an outlier, which is that it's basically just a value in our data set that doesn't necessarily look like it belongs. Meaning it's probably like either way bigger than the rest of the numbers or way smaller than the rest of the numbers. So again, an outlier is a value that's far away from the rest of the data. So for example, if we were looking at this data set, the outlier would be right here because there's a clear gap between the rest of the data and that one data point. All right? Heads up, guys. All right, so that's our outlier. Now, if we were to describe this shape, this is why outliers are a pain, because they can mess with the shape of our data. Because if I did not include the outlier, what's my shape? If I did not include the outlier, it's symmetrical. So, if we did not include the outlier, we would say that this was symmetrical with an outlier. So like an outlier exists, but the overall shape is symmetrical. Now, let's say I did include the outlier. What's the shape then? Skewed right. So, that's why, stop talking, guys. That's why knowing where your outliers are is important. Because a lot of times, if you're looking at data and trying to analyze it, a lot of times what researchers will do is they will throw out outliers because they can skew their data, whether it skews it to the left or to the right. Because typically, when you look at data, you're hoping that it would be fairly symmetrical. All right, that's typically the hope. But if not, there's probably some outliers in there, meaning that they just kind of happened. It was like a once in a blue moon, it just kind of happened. So, like, for example, I kind of talked about this last week, but I told you that whenever a teacher curves a grade, sometimes they will base it off of a symmetrical curve or bell curve. All right? Let's say that most of you on a test, the average was about 65, 70, all right? So, if the average was about 65, 70, meaning most of you got between the B and D range. If someone got, say, 100, that would skew the curve and make it so that it works not in your favor, all right? So, if the curve got skewed, that means it would work not in your favor because it got skewed to the right. Let's say someone made a 0. All right, meaning they just turned it in blank. That's also an outlier. It would skew it to the left because it would be so far away from the other data. All right, so in other words, that would be way too much of a curve. So those are things that teachers as well as researchers have to look at when they're looking at any form of data. Your test grades are data for me. It lets me see what you guys know, what you don't know. And sometimes I will look at the averages and kind of see what's going on. Now, of course, there are some people that do, really, really well above and beyond. Maybe they just, got the topic really well, or they just actually studied. But that is stuff that us as teachers have to consider whenever we're looking at test scores. Even your EOC scores, we're looking at that data constantly. All right? Now, sometimes the outliers are obvious, other times they're not. So, there is a way that you can tell what the data, where the outliers will be, and we can do that using the IQR. So remember, IQR is your Q3 minus your Q1. Now, IQR, or interquartile range, is part of the formulas that we can use to find where your outliers can fall under. So these two formulas for finding outliers. The lower side of your outlier is given by the formula Q1 minus 1.5 times your IQR. And then your upper side of your outliers is Q3, or your third quartile, plus 1.5 times your IQR. Now, you may be wondering what the heck, where do these formulas even come from? The easiest way to explain it is through a box plot. All right? So let's say that I had a fairly symmetrical box plot, all right, where I took into account the outliers. All right, your IQR makes up your entire box. That's the length of your box. Your Q1 is here. Your Q3 is here. Now, let's just make up a hypothetical. Let's say that my Q1 was 70. All right. And my IQR was like 20 or something. But 1.5 is just a number that we use to describe how much of the box we're taking from the IQR. We want this much of the box so we can figure out where the whisker is. So essentially what we're doing is that when we use these two formulas, we're figuring out where these whiskers end. Because an outlier would be not within the whisker. It would be a dot on either side of the whiskers. So for example, let's say after we put the 70 in and we did our formula, we got 30. That means that this whisker cuts off at 30, meaning any number less than 30, for example, say 25, would be considered an outlier. It's not within our box and whisker plot. On the other side, we have our higher whisker. So let's say the Q3 was 100. And this was 120 when we did our formula. That means any number higher than 120 would be considered an outlier. So for example, 130 would be a dot because it's an outlier. So what these two formulas do is that they tell us where our whiskers stop in the span of our data and will make it fairly symmetrical. All right? That kind of makes a bit more sense where the formulas come from. So essentially we're finding the ends of the whiskers. Up until now, all of your box and whisker plots have included the outliers. So they may have been more skewed than what they should have been. But you can also make box and whisker plots with the outliers using these two formulas and then dots to represent the outliers. All right, you still plot them, they're just not what's actually within your box and whisker plot. Now, your calculator, your TI, so remember last week when I explained how to find the box plot in your calculator? It was on that green reference sheet. Anyway, so the box plot that we found was one that included the outliers, but your calculator can also find the ones that graph your outliers separately as well. And it's the same process, just a different button click. All right. Now, that being said, let's actually look at some examples and see if we can figure out what our range for the outliers are, guys. Heads up. I'm not even going to name that with an answer. All right. So, if we're looking at this first example, all right, sometimes the outlier is pretty obvious. What do you think is obviously the outlier? 15. It's way smaller than all of our other numbers. Now, we're going to actually use those two formulas that I gave you to check. Now, I don't really want to take the time to find the median and the minimum and the QR and the Q1, the Q3. I'd rather just have my calculator do it for me. I showed you guys how to do this last week. If I want to do this in my calculator, what's the first step that I got to do? We hit stat. Then what do I do?
No, you have to press enter.
Press enter, and we're going to input our data in L1. So I'm going to highlight L1 if I have something already in it, hit clear, go back down, and then I'm going to enter my data. All right, so that's all my data points. Now, once I have my data, what's my next step? You hit stat again. Remember, anything you're doing with stat, you always hit the stat button. In statistics, we always use the stat button. Then what do I do? Right. You hit the right arrow key so that calc is highlighted. Nope. You press number 1 or you hit enter because we want one variable statistics. So we're going to hit enter and then you're going to hit enter a couple times. And then you get this screen. And remember, your 5-number summary would be at the very bottom, so scroll all the way down using your down arrow key. And just like that, we have our Q3 and our Q1. We don't need to find it. All right? So your Q1 is 60. Your Q3 is 80. So what would your IQR be? 20, because 80 minus 60 is 20. So your IQR is 20. So now we're going to use the two formulas that we know to figure out where our boundaries for our outliers are. So for your lower, I'm going to do my Q1 or 60 minus 1.5 times 20. So do that in your calculator and tell me what you get. So put in 60 minus 1.5 times 20. Make sure you put parentheses around the 1.5 times 20. It's what? It's 70. All right. Now, our upper, we would do our 80 plus the 1.5 times 20. All right, so go ahead and do that. Yes. Oh, 40. Yeah, it's 40. 30. Okay. Yeah, that sounds right. Yeah. All right, so what's 80 plus 1.5 times 20? So what'd you guys get for your upper boundary? What is it? 110. Good. So what this means is that any number on our data set that's less than 30 or greater than 110 is considered, guys, stop talking. If it's less than 30 or greater than 110, it's considered an outlier. So that being said, 15 is 100% an outlier because it's less than 30. All right. Try example 2. All right. Obviously, the outlier is going to be what? 40, but use your IQR formulas to prove it. So remember, you need to find the Q1, the Q3, the IQR, and then you got to find your lower and upper regions or boundaries. And you can use your calculator to find your Q1, Q3. So go ahead and try it. All right, so everyone should be trying this one. You do Q3 minus Q1. So a way to remember it is it's called the interquartile range. It's the range of the quartiles. All right, thumbs up if you're ready. You guys another minute. All right, guys. So check your answers. So your Q1 you should have gotten is 2, your Q3 4.5. If you subtract the 2, your IQR is 2.5. Then if you did your lower and upper formulas, you should have gotten your lower bound as negative 1.75, your upper as 8.25, which since 40 is clearly greater than 8.25, 40 is definitely an outlier. All right. All right, last one. Let's just identify this one. What's clearly my outlier? 24. It's all by itself. There's clearly a large gap between it and the other data. So your outlier is clearly 24. All right, last thing we're going to talk about is spread, and this one's really, really, really quick. All right. So with spread, we're basically talking about how many numbers could possibly be data points or be considered as appropriate data points. All right. And spread is exactly the same thing as range. So it's exactly the same as range. So if I ask you to find the spread of the data, you find the range. So again, just to review, range means you take the maximum of the data and subtract it from the minimum. All right. So, for example, this very first one, how would I find the range? 5 minus 1, which is 4. So your range is 4, meaning that there's about 4 appropriate numbers that could fit our data. What about the second example? Where are they? 90 minus 60, which is 30. What about the last one? What we do? So 300 minus 107, which is 193. So again, all you gotta do is find the biggest number in your data set, the smallest number in your data set, subtract them, that's your range, which is also considered your spread. All right, any questions on any of this? Shh. All right, so for the rest of class, you got a solid 25 minutes. There is a quizzes on this stuff. All right, it's about 20 questions. You get 2 attempts on it. All right, so take your time. It should be almost all multiple choice, but do not just click through. Yes. So guys, just so you can plan ahead, the term ends on Friday. That being said, the test for this unit is going to be Thursday. All right, so it will go on this term. However, this is one of our easier units. So you guys should be pretty okay with this. If you're not, you need to talk to me about it. None, we're done. We're reviewing. So guys, this is the last unit of the content for Math 1. After that, we're in review land. So pretty much all of the last term, we're just going to be reviewing for the EOC.
Wait, so this is our last chance to figure it out?
No, I'll probably have some other kind of cumulative review tests for you guys to practice with. And I'll count them. Huh? I guess. Does that have a tiger on it? Yeah, that's it. Just make sure you do all your delta math for this term or for this unit. Chloe, can you hit the light, please? It's over by the the one by the thermostat. Thank you. All right, guys, I shouldn't be hearing much talking. Make sure you should be able to get this quizzes done. Go ahead and take out your Chromebook, get on quizzes. So I think the name didn't generate. It's the one with the tiger on it. So yeah, mathematical quiz. Yeah. Guys, shh. So it's a quizzes. If you don't remember how to get to quizzes without it being blocked, go through Canvas. It's linked in there. Guys, I should not hear a lot of talking. Get your quizzes done. You can probably knock it out before class is over. Guys, again, stop talking. Get your work done.